What if one of the most advanced machines ever built by humanity is flying above you right now, and you don't even realize how much technology is keeping it alive in the dark sky? This is the Airbus A350, a long-haul aircraft designed not just to compete, but to dominate the future of flight. When Airbus decided to challenge Boeing's wide-body leadership, it didn't upgrade an old design. It started almost from zero. The result was an aircraft built from more than 50% carbon fiber reinforced polymer. Unlike traditional aluminum bodies, this composite structure is lighter, stronger for its weight, and more resistant to fatigue. Every time a plane climbs to 40,000 feet, the fuselage expands slightly because of cabin pressure. Over years, metal weakens. Composites handle that stress differently. The A350 was built to survive tens of thousands of these pressure cycles with greater efficiency and lower long-term maintenance costs. Under its wings are the Rolls-Royce Trent XWB engines, the most efficient large jet engines in service. Each one can produce up to 97,000 pounds of thrust. Together, they can lift a fully loaded aircraft weighing over 300 tons into the sky. Yet despite that power, the A350 is significantly quieter than older long-haul jets. Airports measure smaller noise footprints. Passengers hear less engine roar. But the real intelligence of the A350 lives in its systems. It uses advanced fly-by-wire technology. There is no direct mechanical connection between the pilot's controls and the control surfaces. Every movement is interpreted by computers that calculate stability, performance limits, and protection laws. The aircraft actively prevents stalls, overspeed, and excessive bank angles. In critical moments, it helps the crew stay within safe boundaries. Behind the scenes, the A350 is built with layers of redundancy. Multiple flight computers, independent hydraulic systems, backup electrical sources. If one component fails, another immediately takes over. The design rule is simple: no single failure should ever cause catastrophe. On ultra-long routes over oceans, where diversion airports can be hours away, that philosophy becomes everything. Inside the cabin, Airbus focused on human endurance. The A350 maintains a lower cabin altitude, around 6,000 feet instead of the traditional 8,000. That reduces fatigue and dehydration on 12 to 16-hour flights. The windows are larger. The air is more humid. LED lighting shifts gradually to simulate natural daylight cycles, helping passengers adjust across time zones. It is engineering designed not only for performance, but for physiology. The aircraft comes in two main versions, the A350-900 and the larger A350-1000. Both can fly more than 8,000 nautical miles, connecting cities like Singapore and New York non-stop. For airlines, efficiency is survival. The A350 burns up to 25% less fuel than older aircraft in its category. Lower fuel burn means lower emissions and lower operating costs, critical in an industry where margins are thin and environmental pressure is rising. But before carrying passengers, the A350 faced brutal testing. Its wings were bent upward far beyond normal flight loads to understand structural limits. Engines were tested against bird strikes and extreme weather ingestion. Every software layer was validated. Aviation does not allow uncertainty at 40,000 feet. Now imagine the aircraft at night, crossing the Pacific. Below, total darkness. Above, stars. Inside the cockpit, digital displays glow softly while the autopilot manages course and altitude. The composite wings flex in turbulence, designed to bend rather than crack. The aircraft continuously sends performance data to ground systems, predicting maintenance needs before failures occur. It is not just flying, it is analyzing itself in real time. The Airbus A350 represents a shift in aviation philosophy: lighter materials, smarter systems, greater efficiency, and deeper integration between human pilots and digital control. It competes with the Boeing 787 and the Boeing 777X, but its identity is clear: precision, resilience, and silent strength. At cruise altitude, everything feels calm. Passengers sleep. Cabin lights glow softly. But hidden beneath that calm is one of the most complex machines ever engineered, balancing physics, software, and raw thrust against gravity every second. The Airbus A350 doesn't simply travel across continents. It calculates, adapts, and endures.